recorded coming up. Okay, so what did we see in the last classes? It's regarding your, where is it? So if you have a node connection like this, that is a network where you have here, how many nodes are there? 5 nodes, right? So you can see some connections between the nodes like 1, 2, 1, 3, 1, 4, 1, 5 is there. But there may not be connections between all the nodes. So for example, here you can see 2 and 4, there is no connection. 3 and 4, there is no connection. Yes, so it is missing actually. So in that case, how will you transmit? Suppose if there is no direct connection between 2 and 4, how do you transmit the data if there is no connection? So we have to take the other intermediate nodes. So that was that we saw in Dijkstra's, the cost was updated. So here what we will do is, what is the cost matrix getting updated? You should know here. So this is the initial cost matrix. It is written here. What is it? This is going to be your source. This is going to be the destination node. So when the data is in source node 1 and the destination node is also 1, the cost here is 0. Cost is what? The weight. So here if you see in this source node 1 and source node is 1, destination also 1. Do you have any cost here? No. So in that case, the cost is going to be 0. Next, if you see source node 1 and your destination node is 0, sorry, the 2. Destination node is 2 here. In that case, so here you have so we have the source node as 1 and the destination node as what? 2. Yes, in that case, what is the cost? From 1 to 2, what is the cost? Abhimanyu, tell me, what is the cost of between the node connection 1 and 2? See, all of you should be online. Yes, I'll be asking you questions in between. Abhimanyu? Yes, Abhimanyu, are you online? Hello? Basavaraj?
Yes, ma'am.
Yeah, tell me now what is the cost between 1 and 2?
1, ma'am.
1 and 2. Yes, so same way, 1 and 3 is what? 10. So see this
3,
figure,
3, ma'am.
1 and 3 is what? 10, right? So
10,
you guys
10.
are understanding how to write the cost matrix, initial cost matrix from the node diagram, right? So this is the way we write. Now the thing is, we have to see where we have to provide the highest value, what we consider is what? 100. What is the meaning of 100 here? That means there is no connection between 2 and 4, correct? That means we are going to generate now a path for the nodes where there is no connection, the intermediate path. So 2 to 4, or here we saw what? 2 to 4, there is no connection. 2 to 5, there is no connection. Yes, 2 to 5. So this, there is no connection. It is not there, right? It is not there. So that is not available. So we are going to generate the path. So in Dijkstra, we just we finally created what? The cost matrix. So here you can see the final cost matrix I will show you here. So this is the final cost matrix. So 2 and 4 actually we didn't have any connection. So from the value of 100, we have reduced it to 4. Yes. So this is actually, we are updating the cost, but we don't know the path. 2 to 4, what is the path? So that was done in Dijkstra. Now in distance vector, what you're going to generate is, you will be finding out this final cost matrix by using the iteration method and plus. So you will be generating the next to hop matrix. See, this is the initial cost. You will be generating the next to hop. What is the meaning of next to hop? It is not the destination node. This is not the destination node. It is just, suppose if a data is available in first source node here and the destination node is 4. In that case, what is the next hop it should have? So what is the next hop from 1 to 4? We have to see. So initially what will happen is, this is the initial next hop matrix. So 1 to 1, 1. 1 to 2, it is going to be 2 only. So you see 1 to 2, 1 to 1 is same here itself. 1 to 2, next stop is 2 only. 1 to 3, next stop is 3 only. 1 to 4, next stop is 1 to 5, next stop is 5 only. 1 to 4, again you will be having the next stop as 5. So initially it is going to be the same. It's 1, 2, 3, 4. It is going to be same. You can see here. Yes. So now, what using the formula? This is the formula I told. So using the formula, you are going to update your cost. Using the formula, you are going to update the cost matrix. Sometimes it is not that always we will be changing only the hundreds here, which is not having connection. This 10 also can be reduced. This 20 also can be reduced. So it depends on the formula. So what formula we are using here is, you observe here, this is the thing, but if cost of ij is greater than cost of ik plus cost of kj. So for example, let us see here, one connection we'll see. So 2 and 4, there is no connection, right? So we have to find out what is the cost. We have to find out the next cost. Yes, like other than 100, what will be the other value, that is a new value of your cost we have to find. So how do you find? So means like 2 and 4 you have. I'll just write here. So you have what? So cost of 2 and 4. If the cost of 2 and 4 is greater than, yes. So what is this k actually? K is going to be the iteration. So where is the iteration matrix you observe here? This is the iteration matrix we have k equal to 1. So first we will check for the first row and column. Yes, and then we check for the same way when k equal to 2, second row and second column. Like this we check. Yes, so now when you check like that, here it is not getting updated because it is, we are checking for the first row and first column. Yes, so now next one is, you check for the second row. Here we can see there is change from 100 to 4. Okay, so let us check now. So 2 to 4, what is the next hop we have to find? 2 to 4, this is the 2 and this is the 4 you have. Cost to sublet is 4, we'll verify that. And the next hop is what? Next hop is going to be 1. Only the next hop we are going to generate here in your distance vector algorithm. Whereas in Dijkstra, we generated the path itself. Yes, so now next hop only it is indicating as 1. So we will verify using the formula there. Yes, so now here cost of sources to destination is 4 and cost of what is I now? I is 2 here. And what is k? So if you take k as second, so this already I have told you last week. So if k is equals to 2, we'll see. So cost of 2, 2 and cost of k is what? 2 here and j is what? 4. So what is the value of these things we will see. So the value of 2, 4 is what? The value of 2, 4 is 100. Yes, the value of 2, 4 is 100 here. What is the cost of 2, 2? We'll see what is cost of 2, 2 here. Cost of 2 and the cost of 2 here is, it is going to be 0. Okay. So cost of 2, 2 here is what? It is going to be 0 here. Yes. And same way, cost of 2, 4 is what? Cost of 2, 4 is, actually we should start with k equal to 1 only, then only we can do this. Yes, because cost of 2, 4, it is already we are checking for k is equals to 2 and j is equals to 4. So we will do one thing. So here we will check for k equal to 1. So this is what we are trying to do. The formula you should know here. Suppose if this 100 value is greater than the summation of this intermediate, that is intermediate node here, k equal to 1 or 2 whatever, then what we will do, if it is greater means what? The summation value is less. Yes, for example, if you see here, suppose if k is equals to 1 you take. So k is equals to 1 if we take here, this is first kth iteration, we see here k equal to 1. So now you check for 1 and 2. So if you take 1 and 2 here, we'll check whether the formula is satisfying or not. So let us check. So what will happen? So in this formula, k, that is cost of 1, 2 is what? 1. Cost of 1, 2 is what? It is going to be 1. Yes. Now cost of ik is what? Cost of 1 comma 1. Cost of 1 comma 1 is what? 0 here. This is 0. So it is 0 and plus cost of kj. What is k here? It is cost of 1 comma 1 again. Cost of, because we are finding out what? We are trying to find out what? 1 comma 2, right? We are trying to find out 1 comma 2. So here k is actually 1, j is equals to 2. So cost of 1 comma 2 is what? Cost of 1 comma 2 is 2 here. Sorry, 1. The cost of 1 comma 2 is 1 here. So it is 1. So is it 1 is greater than 1 here? No, it is not greater. So what we will do? We will retain that same value. We will be retaining this, the same value itself. We are not going to take the new value. Okay, so that is what we have here. So same way. So like this, you will be checking for 1, 3, 1, 4, 1, 5. And same way, we'll be having 2, 1, 3, 1, 4, 1 and 5, 1 also will be checking. So, and so that is what we will do. This is what is the formula we have. Yes, now, if you take, so by this way, when you observe, k is equals to 1 intermediate node, when k equal to 1 in intermediate node, so there is no change of value in your first row here. So what we'll have, the next half matrix, it is going to be same only. There is no updation. Or we can tell, so you just observe, or if you see here, what you have here is, let us check for here, for k equal to 1, the values here, what it is. So previously what you had, it is 1, 10, 3 and 20 you had. So here what you have, it is 1, 10, 3 and 20 only. Yes. 1 minute. 2, 1. So if you take this one, we'll check for this one here. Yes. So for this one, that is, let us see 100 what it has happened. So in this case, when you see for 100, so just try to apply the formula. So when you apply the formula for 2, 4, so here only it is changing 2, 4. So it is intermediate node is what here? K equal to 1. K equal to 1 here. Yes. So now it is going to, so you can see here 2 to 4 can go through. Now we are checking for intermediate node k equal to 1. So 2 to 1 and 1 to 4. So you are going to use the formula using MIK. K is 1. MIK is what? 2, 1. MKJ is what? 1, 1 and 4. This is missing 1 and 4. So what is the value here? 2, 1 and 1, 4. If you add, it is 1 plus 3 is 4. This 1 plus 3 is less than the value of your 100. Yes. The less than the value of 100. So what you are going to do is you will make it 4 and the path is what? It is 1. It is 1. So you change this as 1 here. Okay. So you change this as 1. Same way if you see here, this 21 also, 2 to 5. So when you take 2 to 5, but k is equals to 1 only. Yes, so 2 to 5, we are checking for 2 to 5, k is equals to 1. So in that case, 2 to 5 you are checking, k is equals to 1. In that case, what will be the value? So it is 2 to 1 is 1 and 1 to 5 is 20. So 21. So 21 values less than your this 100. This is less than the 100. So by this way, what we can do, this 100 is going to be changed as 21 and the path is going to be updated as, sorry, the next hop is going to be 1. So when you choose 2 to 4 here, is what we will do is, we are changing the next hop as 1 here, next hop as 1. So same way, these all are updated. These all are updated here. Yes, so now same way k equal to 2 we will do. And so you can see here, wherever there is change, there the path will be changed for us. So here this 3 is there and this 6 is there. And so there the path is going to be changed. So here you can see for k equal to 2, when it is 3, the path actually, the next hop is changed to 2 because k is equals to 2 here. Is any more change you see? And then for here actually it was 4 only. So it is retained as 1 only here. So we retain it as 1, no issue. If you see 6, it is changed to second. So what is the meaning of this is, when you have source node as 3 and destination as 4, the cost is reduced here to 6, new value. And what is the next hop is from 3 to 4. From 3 to 4, what is the next hop the data has to go is 2. That is what is k equal to 2. So like this you will be finding out. So here it is updated. Okay, so one more thing you guys should observe. Yes, so that is what you can observe here. This path actually, this vertical row, we are changing it as 1, 1, 1, 1, 1. The same way, next also will be changing 2, 2. But here it is already updated for you. It is already updated, so we don't change that 1, 1. But here, okay, it is already 1, 1 only. Okay, so not an issue. So only thing is you have to check for the formula here. Wherever you have lesser value, you apply and change the value of your next hop. This is called next hop. See, next hop matrix for k equal to 1. That's it. So same way you keep till, so how many number of nodes you have, that many iterations will happen. 1, 2, 3, 4, 5 nodes are there. So k till k equal to 5 you will do. So k equal to 2 is done, k equal to 3 cost is done, and then next hop is done. Yes, so now what is the next hop is, how do you decide the next hop values? Yes, so if k is equals to 1, then we are replacing with 1. That means the next hop is nothing but what? Based on this iteration, k equal to 1 we do. Same way, k equal to 2, the iteration, we are taking this as the next hop. Yes, so same way you can observe for k equal to 5 we will see. So here the value, this 5 is alone changed. Previously what it is? Previously it was 3, 4. What is 3, 4? We will see 3, 4. This 3 and 4, you observe it is 6. Yes. So now these are the updated paths. That is next hop we have given. So it is 6. Now we have to check the previous table. So if you want to check now 3 and 4, and the intermediate node is what? 4. So now we have to have, so it is 3 and 4 plus its destination is 6 only. Wait one. 3 and 4. M of 3 comma 4, if it is greater than M of 3 comma 4 plus 4 comma 4, like that. See here the formula we have to use. M of I is 3, J is 4. Destination node is 4. Source 3, destination 4. Intermediate node is what? K equal to 4. So it is like M of I, J. What is that? 3 and 4. This is Mij. Yes. We have to check whether this is greater than the sixth value, whether it is greater than M of what is I k. K is what? 4. So it is M of I is again it is 3 comma 4 only, plus what do you have next is M of 4 comma 4. Yes, it is 4 comma 4. 3 comma 4 is what? 6. So 6 plus 4 comma 4 is 0 you have. So 6 is greater than 6 we are getting. So in that case, if you follow the formula, so it has to be checked. Oh, sorry. So we are checking for k equal to 5. In that case, what we should do is, it is 3 comma 4 is the destination, source and node. Yes, now we have to check with 5 as intermediate. So 3 comma 5, M of 3 comma 5 plus M of 5 comma 4. So this we have to check. These are the cost of 3 comma 4 if it is greater than this 2. So this table we are going to create, we have to find out what is this value. So what is 3 comma 4? Previously it is 6 here. Now what is M of 3 comma 5? 3 comma, from here we'll see what is 3 comma 5. 3 comma 5, here it is 4. So what it is? This is going to be 4. This is going to be 4. And what is 5 comma 4? Right? It is 5 comma 4. What is 5 comma 4 is nothing but 1 here. Yes. So when you want to update a new table, you have to use the values from your previous table. Very simple. So this is 1. So in that case, this 6 is greater than 5. Correct? This 6 is greater than what? This 5 value. In that case, we'll be implementing the formula. So you will be replacing. The formula tells what? If it is greater, replace this cost by the new cost. Update the cost. What is the new cost you got? It is 5 here. So that is why we are replacing 6 to 5 here. When you replace it, you have the intermediate node, that is the next hop is also 5. So just we are finding the next hop here. For example, 3 to 4, now the next hop is 5. That is, you have the last node, we'll check. We'll check for, from this table we will check. So we saw 3 comma 4, right? So for 3, from here to transmit, as there was no connection, the next hop we are choosing is 3 to and 5 and 5 to 4. This is the actual path. But what is the table telling? The table is telling only about the next hop. Next hop is 5. Whereas in Dijkstra, what it will do is, for each iteration, if you want to do from 3 to 4, it will check. Okay, this is one path we have. Yes, and then this is one path you have, and then directly there is no path, and then you may have this path, and then you have this path also. So you have the other path as what? So you have will be having this path. So this coming this way also is one path. So there are how many possible paths? 1, 2, and then 3, 4 paths. Totally 4 paths are there. There are 4 paths. Yes. So in that 4 path, it will take the minimum cost. So if you take the minimum cost, it is, this is 2. This path if you take, it is 2 plus 1 plus 3, it is 6. If you take this path, it is 10 plus 3, 13 more. Then if you take this path, yellow color, it is 10 plus 20, obviously more. Finally, if you take this path, it is 4 plus 1, 5. So final path will be this. But your distance vector algorithm is going to generate only the final cost matrix from one node to another node, source to destination, and what will be the next hop. That is the criteria. Only that you should know. Okay, so for each iteration, the cost matrix. So you can see here the cost matrix, and then the next hop matrix is done. Okay, so this is actually distance vector. So same concept only as we saw Dijkstra. Now we'll see the code. So you see the code here. I'll open Dev C++. Yes. So I want everybody to write down the code. Okay. Parallelly, as I teach you, you write down. So now, so we have the main file here, stdoi.h. Okay. And next is we are opening the main function into main. And so what is the difference between your the Dijkstra and distance vector? We have to see. So what is Dijkstra? I just opened that also. We have it. So this is the Dijkstra algorithm. Yes, this is Dijkstra. This is distance vector. So in Dijkstra, what did we do is we found out finally. What did we find out is we found out the cost matrix and your, this is the cost matrix. So we found out the cost matrix here, final cost matrix, and we found out the path using this function. So using this function, we just displayed the path. Like suppose 3 to 4 means it is going through 3 to 5 and 5 to 4. That path was displayed. Yes. So what is the difference between the program alone? I will tell. Path is displayed here through this function. Yes. So only difference here is, so here everything is same except this, it is written as cost, and we are not having any call function for path. Yes. So we'll be having cost and then next path, next hop. So you see the cost is nothing but previously m, it is cost here, next hop. We are declaring for 20 cross 20, row and column, 20 cross 2-dimensional matrix, 20 cross 20. Yes, so other things are same. Yes, the printf, enter the number of nodes. So same thing is there, enter the number of nodes, node connection, everything. First, we should get the cost matrix, initial cost matrix. So this initial cost matrix we should display. This initial cost matrix we are trying to display, we should get the data from the network, from this network. So for that, what we are doing, this is the for loop which will be helping us in printing the cost matrix. This cost matrix will be printed for us. So that is what is this one. Same thing in distance vector also. Yes, only the variable is changed. Yes, here it is cost. So you're getting the data from cost ij for each row and column I equal to 1 and j equal to 1 to 5. So for each source node to destination node for 5 cross 5 matrix, we are doing this. And what is the difference? So this is the difference in your distance vector. Here we were trying to find out the path. So initially the path is declared as 0. But in your distance vector, what are we doing? Path is not found out. We are trying to find out the next hop only. And finally, we will display also what is the routing table for each node. We will display. So instead of this P of I comma j path, we are having next hop, that is I comma j equal to j. Why we are having like this? To get this table. Next hop initially is what? 1 to 1 means it is 1 only. 1 to 2 means next hop is what? 1 to 2, what is next hop? 2. 1 to 3, what is next hop? 3. So this table we will be getting. That is in the first one. So this is a change when compared to you have to check with your Dijkstra. Next is same thing. See, next what we are trying to do, Dijkstra also we had the same thing. So K is going to indicate your iteration. I is nothing but source node. J is nothing but destination node. Yes. So now when K is equals to 1, this is which one? This is the K equal to 1 iteration ka the cost and next hop matrix we have to find. Yes. For that, what we are doing in distance vector also, in Dijkstra also, this is same. Only thing, instead of path, next hop you have to give. Yes, here what is, so you can see here. So when here, we actually, if you take this one, when K is equals to 1, first case is what? When K equal to 1. And next what we will do? For loop, internal loop we have. I is equals to also 1 first we will take. Yes. And next, when I is equals to 1. For I equal to 1, what is the destination node? J. So J is equals to 1 we will have. Yes, so for K iteration 1, I and J is 1, 1. Check out whether the present value is a lower value or not by this formula. And you will update the source and destination I11. That is, Ij is what? 1, 1. So you will just create what you're trying to create now. So for K equal to 1, I equal to 1, J equal to 1 is over. Next, what you will do? For I equal to 1 itself, you will be checking for what? You'll be checking for J is equals to 2. So here it is cost of 1, 2. You will update. Next is J equal to 3. Again, you will check for the value, update. Next is J is equals to 4. So it will go on this when I equal to 1, for the J internal loop has to be completed from 1 to 5. What is the end? That is our declaration. So we have taken 5 cross 5. Yes, so now for I equal to 1, J 1 to 5 has to be done first. Then I equal to 2 it will become, and next J equal to 1 to 5. For each source and destination, you are going to update your cost matrix. When you update your cost matrix, whenever there is a change in the cost matrix, see here, whenever there is a change in your cost matrix, here what we are doing in the next hop is going to be 1 here. Yes, 4, 21 we have, it is changed to 1. Previously it was what? 4. It was 4. So what is this one indicating? It is the iteration mode, that is K value. So in your code, you can see next hop is nothing but what? Next hop of whatever source or destination, it is going to depend on the K value. So this is how for K equal to 1, if you see, the next hop, we are determining in this way. The next hop, if there is a change, this will change. Otherwise, it will not change. Okay, this is what is your next hop, that is finding out your cost and next hop over. Yes, so okay, so now I have just told the iteration like this, it will go on K1, 2, 3, 4, 5, it will go on. So finally, then we have to display. The display part is there. So first you write down this one. So till what I have told is, I have told for K equal to 5, till K equal to 5, how to get the current cost value and what is the updated next half. That is what is calculated now. Okay, so till that. So I want everybody to write down now. So write down. I'll give you some 10 minutes. Take down this. I'll be seeing your observation. So same document you upload. Is are you guys taking down? Yes. Murli Mohan, Suchitra. Suchitra, are you there? Suchitra. If you guys are not answering, then I can't consider the attendance for the session. Suchitra, Surya Teja.
Yes, ma'am, I'm there.
Yeah, you're there. Surya Teja.
Yes, ma'am.
Yeah. Are you taking down the code?
Yes, ma'am.
Hmm. Take down. Others. Abhimanyu Raju. Abhimanyu. Abhimanyu is going to be absent now. Vinay Kumar.
Taking down, ma'am.
Taking down.
Abhimanyu has some mic issues, ma'am.
Who? Who is having mic issue?
Abhimanyu, ma'am. He has
Abhimanyu.
messaged in the inbox.
Oh, yes, message. Sanjana. Okay, take down. So once you complete this page, you tell me, I'll scroll down. So you need to tell me, one of you. Yes, I have muted myself because you're taking down the code. Once you are over, completed the part, you tell me. I'll scroll down. Yes? Hello? Is it over? Is it over?
Yes, ma'am. The slide completed.
Yes,
Completed? Then
yes,
next.
ma'am. You can
So till this
scroll a little.
node connection that you would have written, this for loop I will show you now. This for loop you take down. This is to get the cost from the network. Cost you are going to get from the network and display the next hop, the very first 2 by 2, that is 5 cross 5 matrix. After this, iteration will happen. Take down this.
Ma'am, can you extend the time, ma'am?
Scroll. Can you scroll down more? Thank you.
Now this is the iteration for loop. Take down this.
Ma'am,
Yeah, tell me.
can you extend the uploading time code? Up to 5 have classes.
Oh, is it so? 5
Uh,
now only lab you have, no? After this, what
after,
class you have?
after lab, we have T-While classes, ma'am.
Okay, 7 o'clock?
Yeah, okay.
Okay.
Scroll down.
Is it done?
Yes, ma'am.
Yes, Manas.
Okay, so now next is, so till this we have done. So what is the function we have completed till now? Till k equal to 5, yes, we have estimated or calculated the cost and the next hop. So we have estimated. Now we have to print it. Yes, this is all just estimation, right? Formulas. Next, we have to print the cost matrix and print the next hop matrix. How do you print? So it is like just calculations have gone. Yes, so now how do you print it? So first, the printf statement to just indicate it as cost matrix, and we are providing a new line. And now, as it is 5 cross 5, we'll be having, that is one. This is to generate your column. That is this is to generate as what, I is equals to 1 till 5. So it will come as 1. This is 1, 2, 3, 4, and 5. It is column. It is called as column is generated. Next again, what we are trying to, what is this for loop required us? So this is to indicate this one. Next for loop, it is for down, means like it is row wise we have entered here. Same way we have to enter column wise also. Yes, so column wise means, so we it like 1, 2, 3, 4, 5. Then, so in this manner we have to generate. So first for loop is to create your this 1, 2, 3, 4 in row wise, and next for loop is to generate column wise. Then for each cost, the values whichever is estimated will be stored here. That is getting printed. So that is the use of two for loops here. One is for row and one is for column is generated. Yes, this is done. So how you get generated by new next line is, see difference between this printf and this printf you have to observe. Here you are providing only one tab. After one, when once the I equal to 1 is printed here, we are providing one tab space. So we provide one tab, then tab, tab, tab. Same way, when you want to display this manner, after one, yes, we have to provide next new line. So you give what? Just one /n and one tab. Yes, so because when you give one tab, we have to provide, so that it will be giving, the cursor will go and sit here, so that you'll enter the value of the cost matrix. Next, finally, once this row and column is displayed, then we have to get the value. That is, for j is equals to 1, it is not getting, already we have calculated, so now we have to print. So here if you see, for I equal to 1, you have an inner loop here. For j equal to 1 to 5, for I is equals, this is the source node. Which is source node? This is source node, this is source node, and these are the destination nodes now. Yes, so for I is equals to 1, j equal to 1 to 5, what is the cost estimated? This we have to print. So line by line it will print. For I equal to 1, j 1 to 5, you are going to print what? The cost. Same way, I equal to 2, j equal to 1 to 5, you are going to print the second row. You are going to print, when I equal to 2 and j is 1 to 5, you are going to print the second row. So this is what is happening in this loop, for loop. Yes, so this is done. Next is one print, new line is given. And next what we have to create is, if you see here, the final one, the cost has to be printed, the next hop has to be printed. Yes, this next hop we have to print. How do you print the next hop? Same way we have to use, but only thing is what? Instead of cost matrix, it is next hop matrix here. You generate the row, you generate the column, and when you generate the column itself, so this is like column we are generating. When you generate the column itself, you need to, that is why you can see here, for loop here, you don't have any like open, loop is not open. But for this we are opening a loop here. It is two inner loop because it is already created 1, 2, 3, 4, 5. When you create one I in the column side, so source and destination is coming. So for I equal to 1 to 1. So 1 to 1 means this is created, and this is getting created. Yes, when this j, that is when this I is equals to 1, and next you will have the inner for loop, that is for the j condition. So you will be checking I equal to 1, j, all this condition, what is the next hop we have to get. So that is operation of this one. So you have same thing for row, column, then internally you get the j loop 1 to 5, and immediately you get the next hop values also. And then next what we have to do, So this is what the final cost matrix, final next hop matrix. Only the next hop where the data from one node has to go is displayed. So other than this, what is the main feature of the distance vector routing table is for each node, this is a node, right? So if each node, it will be displaying for from one node to all the other possible nodes, what is the routing table that we can display. Yes, so now that is what is the last one. So what is that is going to display in the routing table I told? So here in this diagram you see, for each node there is going to be maintained a routing table. So what are the things that we are going to maintain in the routing table? Suppose if the router, we are going to generate now router 1, routing table 1, routing table 2, routing table 3, 4 and 5. So what are the contents we are going to have is, routing table 1 means source node is going to be 1 only here. Source node is going to be 1. And destination node is what? Destination can be 2, 3, 4 and 5. And next is cost can be given. What is the cost for this particular destination? And what is the next hop for this particular destination? So that is all generated from where? Already calculated cost and next hop matrix. Do you understand? So now this we have to generate. What we have to generate here is, once more I will tell you. So here we are trying to do, suppose we are trying to generate here the routing table for each node. Routing table 1, routing table 2, routing table 3, routing table 4, routing table 5. What all you will have is, this is going to, so routing table 1 means the source node is this one. Destination, so you are going to generate routing table as, so you'll be having the cost, then next hop, and then one more is the destination node. The top one is destination node. So all this will be printed. Yes, so suppose if source node is 1 and your, 1 minute, one more parameter we have to take. So one more parameter here is, yes, so here the destination node, next hop and cost. Yes, that is what is displayed. The destination node, next hop and distance has to be calculated, printed. So same thing you will be doing. So for example, source node is this one, J is going to be 1 means that is a destination node. So this same J is only going to be what your destination node. The next hop is from the table we have to get, and cost also from the table we have to get. Yes. So it will be coming as this manner. We'll be getting it as, I'll just run and show this so that you'll be understanding easily. So this is the code for your distance vector routing algorithm to calculate the cost and the next hop matrix, and to generate the routing table for each node. What is the destination node for the particular node, and the next hop and the cost. Yes, we'll run and see. So now I'll ask questions. All of you be alert. So it is, no errors has come. Compile and run. So what you can observe, so you guys are going to answer me. Did you take down the cost matrix? All of you? I'll call somebody. You just tell me. So, yes, Monica, how many number of nodes we are using here?
Ma'am, two.
What is the number of nodes we are using?
Two, ma'am.
2. Is it so? How many nodes are there in the diagram?
Diagram.
Then why you told 2 here? Yes.
Sorry.
So nodes is 5. Yes. So once I give this and enter, what it is coming here? I think you're able to see.
Ma'am, we can see our screen.
You're not able to see my screen?
Yes, ma'am.
Ma'am.
Only your pic is visible.
You want to see bigger? Okay, 1 minute.
The screen.
Not required. Is it now viewable? Just wait a minute. Now you can see. Is Mervin, are you online? Mervin, now you tell me the cost matrix from this node diagram. Tell me the cost matrix. Have you taken down this?
Ma'am,
Have you
nothing is
taken down this
visible.
node diagram? Anybody
Ma'am,
can check. Ah,
ma'am, screen sharing might have become off, ma'am. Check once,
oh,
There
ma'am.
is no screen at all, ma'am. Only the ceiling is visible, ma'am.
okay. Wait. 1 minute. Google link. I'm just connecting back. Oh God. Internet is not yet connected. 1 minute. Wait, guys. Okay. So now you guys check. I'll share. I got logged out. Yes. So now maybe you'll be missing. So now from this node diagram, all of you take this node diagram. All of you take down the values correctly. Yes. Based on this only, we'll be creating the table. Complete this and tell me. Just taken down the node diagram. Yes, guys.
Yes, ma'am.
Completed. Now you are going to answer me. Okay. Mervin, tell me the node
Yes,
matrix.
ma'am.
The cost matrix. Where is Mervin?
Ma'am,
Mervin?
yeah,
Yeah.
ma'am.
Tell me, ma. Now tell me the cost matrix.
It will be 1, 2, 3, 4, 5, ma'am.
Between, this is source node. You are able to see my screen, right? Source
Yes,
node.
ma'am.
This is your destination node. 1, 2, 3, 4, 5. So tell me what is the value between 1 and 1.
0, ma'am.
Then, see, I'm pressing 0, providing tab. Okay, then.
1 to 2, ma'am. It is 1,
Ah,
ma'am.
it is 1. Good. 1 to 3, tab. You have to press
10,
tab. Okay.
10,
Okay.
ma'am.
1 to 4,
3, ma'am.
3. 1 to 5,
20, ma'am.
20. Then press enter. You will get now source node to be 2 and destination node 1 to 5. Okay, so one of the other. Harika. Yes, Mervin. Okay, fine. Harika,
Yes,
you tell
ma'am.
me now for source node 2 and destination 1 to 5. Take the
Ma'am.
node diagram.
Yes, ma'am.
From node
2
diagram, 2 to 1 is what? 1. 2
1,
to
ma'am.
2 is what? 3.
0.
0. 2 to 3 is what? 2.
2, ma'am.
2 4 what it will be?
0, ma'am. Sorry, 100, ma'am.
2 to 5.
2 to 5 also 100, ma'am.
Okay, you guys are getting that. So I will enter the value. You're able to find out that. I will enter the value directly.
Ma'am, should it be 100 or any value, ma'am? Because
It is actually infinity.
yeah,
It is actually infinity. When you keep infinity also, obviously when the condition of the formula is satisfied, no, you will write the smallest value. Even if it is infinity, we are having a highest value of 100. That's it. To indicate 100 as there is no connection between the nodes, we indicate 100. Okay, it can be 200 also, not issue. So now I'll just fill this 1, 0, 2, 100, 100. So it is 1, 0. You also cross check 2, 100, 100. Next for when source node is 3. When source node is 3, what are the values? 10, 2, 0, 104. 10, 2, 0, 104. 10, 2, 0, 104. Next for source node when it is 4. This much only it is expanding. Source node when it is 4, what is the value? 3, 100, 100, 0, 1. 3, this is the initial matrix. 300, 100, 0, 1. It is 300, 100, then 0, then 1. Next, last source node 5. So what it is? 20, 100, 410. It is 20, 100, 410. Yes. So now you have got only the cost matrix. This is the cost matrix. Now you parallelly see the code. So what is that we have seen? In the last part you have tried also. So what is that we have got now? We have just got the cost matrix, accept the cost matrix from the user. I have typed. The next hop it is generated, but we didn't print it. Okay, we have not printed. We're initializing that as the thing. Next is iteration. The next, what is the print you will get? The printf is what? The final cost matrix after k equal to 5, fifth iteration, and then you're going to print your next hop matrix. So this both should come. Yes, we'll see that. So when I press enter here, you should get the after kth iteration. What happened? Again, once we come out of this, again we have to enter. That is the thing we have. Getting compiled. Is it happening? Wait for a minute. So again we have to enter. This is the only issue we have. So can one of you read out? Have you written down? No. Yes? Who can read out? Mervin?
ma'am, 0,
Yeah. 0. Then?
1,
Ah.
10,
Hmm.
3,
Hmm.
and 20, ma'am.
20. Next row you tell me.
1,
1,
0,
0,
2,
2,
100.
100, 100. Right?
Yes, ma'am.
Okay. Next one.
3, 2, 100,
Ah.
2,
Ah.
0,
Ah.
100,
Okay.
and then 4, ma'am.
4. Next.
3,
3,
100, 100,
100, 100.
3 to
3 to 4 to 4 is
4
0.
to 4, 0, ma'am.
Ah. 4 to 5.
1, ma'am.
Okay. Next. 5 to 1.
100, ma'am.
Okay. 5 to 2.
2 to it is 100, ma'am.
Okay. 5 to 3.
4, 1, and 0, ma'am.
4, 1 and 0. Yes.
Zero.
So now we should get what after kth iteration. What is the updated this cost matrix? What is updated there? What is the next top? This is the final result. So totally it is coming. Let us see. With the code we will see. So this is what Mervin told me. This is the initial cost matrix from the node diagram. Cost matrix. This is after kth iteration. Yes. So now this 100 is changed to what? 4. This 100 is changed to 5. And this next 100 is changed to again 5 here. So the updated cost matrix has come and the updated next top matrix. So initial, how do you differentiate from initial next top and the updated one is, so you initially, what is the next top is the destination itself, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, everywhere it is same. Whereas here you see now instead of 3, it is 2, means like when you have source node of 1 and destination node of 3, the next hop is means like the next node where the data will be transferred is to the node 2. That is the understand. This is indicating only the next hop. Yes. And same way 4 to 4, if you see, it is like destination is same, right? So it will be there itself, 4 only. The next hop is 4 itself. From 4 where to 4 where it is going, next hop is 4. Yes. So that is what is updated here. Yes. So now we'll check with the table here so that you will have the confirmation. So just see the last table. Cost matrix, it is 0, 1, 3, 3, 4. Here you see it is the cost matrix 0, 1, 3, 3, 4. 5, last row I will check 4, 5, 4, 1, 0. This is 4, 5, 4, 1, 0. So cost matrix is matching. Is correct. Now same way next to hop you see 1, 2, 2, 4, 4. This third was changed to 2. 1, 2, 2, 4, 4 you have. Same way fifth one you see 4, 4, 3, 4, 5. So in this it is 4, 4, 3, 4, 5. Here this first next to hop node and the second next top node is updated. So this is what is done in the code. Now next is finally routing table we have to display. That's it. This is the part for your routing table display. Yes. So here as I told, we are going to print what? The printing is what? Routing table information for router. Which router? Router 1. So we are introducing a loop here. I equal to 1 to 5. I equal to less than equal to n. Yes, n is 5, right? So here you observe this output. Routing, it has to display as what? Routing table information for router I. I is 1, 2, 3, then 4, and then 5. So what it has to display inside? It has to display destination, one tab space, next hop, one tab space, distance. Means like it is nothing but the cost we can tell. That is distance nothing but cost. Okay, so here you see, so distance is nothing but what? Cost. So for that to get as it is in terms of matrix. So if the source node is, this is the source node. And if the router, we are generating a routing table for source node 1. If the source node is 1, destination node is what? 1, 2, 3, 4, 5. So for this, we have to have a loop inside. So j equal to 1 means, in that case, what is the next, what is the destination node? It is j itself. Next to hop from the table we have to take, that is it is going to be what? Source node is 1, destination node is 2. So 1, 2, what is the next hop? For 1, 2, what is the next hop? 1 and 2, next hop is 2 itself here. So see here, for source node 1, destination node 2, next hop is 2. What is the cost for 1 and 2? So cost is actually here 1, check here. 1 to 2, what is the cost? 1. Yes, you can see here, right? So this is the way we have to print. So how do you print this? How do you print it in using C code? Create a for loop and then you're getting the values already, that is this jth value getting from this loop, next hop from the matrix already stored, and cost from the final matrix. So it has to be displayed in this manner. See, the thing is how you want to display. So see here. So first I'm displaying the destination node. I'm getting the jth value. So percentage j, destination has come. One tab space is given here. After giving one tab space is given here. Next hop. So next hop, where is the next hop value stored? Next hop, ij. So from there, I'm going to store with one tab space. See, percentage tab, yes. And here two tab is given, not required. One tab is sufficient. If you remove one tab space, here it will little bit come nearer. That's it. Two tab space we have given here. Here it is one tab space. Here it is taken from which? The cost matrix. You can see it is taken from cost matrix. Next, when j equal to 2, then j is equals to 2. J is what? Destination 2. So this j loop, this is for displaying when the source node is 1 and the destination nodes are 1, 2, 3, 4, 5, what are the parameters we are updating? That is for routing table. This is for 1j, that is when j is equals to 1 itself. J is equals to 1. When, so this is routing table for 1. Routing table for 2 means what you will display? Where the source node is going to be 2. From 2 to, if the destination node is 1, 2, 3, 4, 5. 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5. So for each node, we are generating the routing table like this. What will be the next hop and distance or the cost to tell? That's it. So for all the routing table, the nodes, we are displaying the routing table. That's it. Any doubt you have here? You can ask me. So if you don't have any doubts, so till next hop you have written.
Yes, ma'am.
Okay. So now you write down this routing table, this display information you write, the code you write. Today only 19 people were there. Only now 3 people are left. Why? Take down this. This is for routing table generation for each node.
Scroll up, ma'am.
Should I scroll down?
Yes, ma'am.
Yes, finish. Guys, done?
Yes, ma'am.
Sir, what do you do, sir? 5 minutes. TikTok. Preeti, no. Hmm.
That's it, ma'am.
Yeah, that's it, ma. So before 7 p.m., I will share this code in Google Classroom, and then the PPT also. Is you guys try to view the output. Okay, output also one snapshot I will upload. But I want to see the full document. If previously it was not full, it was some snapshot, screenshot, everything was there. Full written code and output with your what is the node diagram. That node diagram you have to have, and manual calculation. That PPT also will upload with manual calculation also you upload. So three things you need to upload: node diagram with calculations, code, and your output. All these things you guys upload this time. Yes, and I will send a Google form as quiz. So you complete it by tomorrow. I will give time to complete. Tomorrow morning I will upload. Yes, in the Google Classroom itself. Okay. Thank you guys. Thank you for the session. You can leave the
Thank you,
session
ma'am.
now. Yeah. Thank you. Thank you.